Okay, we just went over the earthquake example. Now we're going to be talking about decibels. This is the equation that they use to figure out how many decibels something is at. I'll give you an example of how I used this in the real world recently. I was sitting in a movie and I was like, this is insanely loud. It was the previews for the movie. They were so loud. I was like, it was hurting my ears. Like it was literally painful. I had to like cover my ears because it was hurting. All right, and I was like, how do you prove to somebody that the music is up too loud or that that it's not safe? So I took out my iPhone and I have a decibels app on it, and I took a picture of the decibels that were happening at that moment. Let me show you what it looked like. Could you read that to them? 110.7 on the decibel little meter. And I was able to take a screenshot of that and then show it to the manager, who did end up turning it down. This old couple sitting in front of me finally left. They just couldn't take it anymore. It was just hurting, and they were like, this is stupid. They actually went and talked to the manager before me. They didn't believe them. I brought this and said, it's 110, okay? 100 is right on the borderline of causing damage. 110, it's causing damage. And when it's causing damage, that means permanent, like you will never hear that well again for the rest of your life. I'm not saying you'll instantly half deaf. I'm just saying slightly worse hearing for the rest of your life. So don't ever let somebody just like, oh, surprise, I put a speaker up to your ear and blasted your, like, at least don't you do that to somebody. Maybe you can't control somebody doing it to you, but you blast some music in a person's ear, you will do permanent damage. So anyway, if we're going to use this formula, you have to understand a little bit of how to handle these logs. If I said 10 to the negative 12, it'd be really easy because those would be the same. And 10 to the negative 12 over 10 to the negative 12 would turn into a 1. And then you got a 1 in the argument, and what's the answer? 0. And that is like the sound of silence song. But anyway, all right, so what if you don't have 10 to the negative 12? What if instead you have 10 to the negative 6? Then you have to understand how to simplify. So everybody, act like this is your test question and try to answer the first 3. I'm going to pause for a second. Let me give this a try. Just to make it clear, I am adding this problem to the kids' homework that we've done in this section so that when we eventually grade it, this is one of the ones we're responsible for. All right, I'm going to hold for a second while you work on that. I'm noting in part B that it says 115 decibels to get permanent, let's see, damage to your hearing can start a short-term exposure to sound levels around 115. I think they've actually, since this thing was published, they've actually decreased it to 110. Because when I looked it up, like old rules, new rules, I think they basically were realizing our ears are more sensitive than we thought. So even 110 will cause damage. So anyway, they're talking a very small amount of damage, but why would you want to be permanently damaged for the rest of your life? Yep. Cool.
So like it will always detect it, and then just over 90, it like alerts you, and it's like
So if you're putting your headphones on, or do you mean?
Don't be detect headphones. So it's like outside.
Oh, like around you,
yeah.
Noise around you.
Right now it's like okay, but if I'm talking closer to it, it says like loud, long-term exposure may affect your hearing.
Interesting.
And it'll
so it warns you at 90?
90.
Oh, interesting. Okay. And that's long-term exposure to this will cause. But if you were in a factory, for example, and I'll bet you that there's some people that'll wear their Apple Watch to work, and they will be like, crap, I'm in an area where if I have long-term exposure, like you were working on the factory floor, and I keep getting exposed to this, it's going to damage my hearing. So if you work at a place that's super loud, yeah, that could be really handy. All right. Did you figure out that you'd put in 10 to the negative 6, and that when you have exponents like this, that you subtract them? So that's 10 to the negative 6th minus negative 12, which makes 10 to the 6th. So all of this here simplifies down to 10 to the 6th. So it's 10 times log, and I always say if there's no base, you should put in the base. And that, I hope you can see, oh, base is the same. Answer's already there. 6. All of that is 6. You times it by 10 and you get 60 decibels. Raise your hand if you had 60 decibels. Okay. All right. We'll talk about it later. Okay. Part B. So it's saying 115. Well, where do we put the 115? Is that the intensity? That's not where you put it. You put it here. How are you supposed to solve it when you have the 115 here? We're going to solve for I. This is our variable. Okay? I agree. Divide by 10. And now you got 11.5 equals log of I over 10 to the negative 12. Oh, and there's no base, so I'm going to put a base. Because the next step I will do is so much easier to see when you have that base there. Because I'm all of a sudden stuck, and I bet a lot of you guys are too. And what advice did I give you whenever you got stuck in a logs unit? Rewrite it. So then that's 10 to the 11.5 is equal to that. And is I alone yet? Nope. But I'm really close. Instead of, you can just simply multiply both sides by 10 to the negative 12th. So I'm going to take this and go, let me move it over a little bit. 10 to the 11.5 times 10 to the negative 12. And then I've got these two, which again, I don't have to like use a calculator here. If this had been a to the third times a to the fifth, you would have said it was a to the eighth, right? You just add the powers. So I'm just going to add the powers. So that's 10 to the negative 0.5. And that is a square root. And so this means the square root of 10 except 1 over it, because they're negative in the power. 1 over the square root of 10. Now I know I didn't get a decimal, but I got a super exact answer. It's more exact than having a decimal, because a decimal would have to be rounded, and that answer is not rounded. Now I probably simplified that up more than you would have, but I hope you can see you just have to plug these things into the right spot in the formula and solve. All right. And if we were going to do C right now, all you'd have to do is, it says compute L of 1. Oh, I just have to put in a 1 right there and figure out that answer and compare it to the, we're comparing 140 to 115. So you'd have a pain threshold. I'm sure you would be in pain at that 140 decibels. One thing that I think is fascinating about decibels is it is possible for you to hear a noise that is so loud that it can kill you. I know you'd probably heard of going deaf from a really loud noise, but isn't that a weird concept? A noise that is so loud that it kills you. It's because it creates a shock wave, and that apparently, just basing this on the Google search, can destroy your lungs. So I don't know exactly what it would be doing to them, maybe like rattling them apart or something. I don't know, but a really loud noise could kill you. All right, and then the last one I want to give you is this one, and it's another great real-world example of logs, and that is pH. So on the pH slide, do you guys know pH naturally? Have you learned it in science or something? Okay, so what's neutral? 7. there's basic and there's acidic, and there's this scale from 7, where 7's kind of in the middle, and 7 is nice and like neutral and normal. And what's common? What's a common thing that's at 7? Water. Good. Okay. Then how about acidic? Are those the small numbers or the big numbers? Acidic is the small numbers. Yeah. And one of the things that I found interesting about this is when I looked up the acidity of soda, as in pop, it is super acidic. And you might think, oh, it tastes good, to you, and it does, I'm sure. They sell tons of it. It must taste pretty good. But it's really acidic. Now, do I think that just putting something acidic in you is automatically bad? No, you have acid running around in your stomach right now. And if you didn't, you couldn't digest things. Okay, so it's not like acid is just innately terrible. You use it in your body. But if you could just pop a tooth out, okay, and then drop it in a glass of pop, it would dissolve within a couple days. It would be gone. The tooth would be just gone. So I think that is kind of fascinating that it's that strong of an acid that it would just simply dissolve up your tooth. If you get a tooth knocked out in hockey, did you know that they can just put it back in? As long as the tooth isn't damaged too badly, they can just actually get it back into your gums and it'll just reset in there and it can stay. So it is actually possible that you could remove a tooth, put it back in. Just don't put it in a glass of pop for a couple days while you're in the meantime. So, all right, this one's another good real-world problem with the formula right there for pH. Big surprise, it involves logs. There's another one that I haven't even mentioned yet that involves how thick the grains of sand on the beach are. And that's a log formula also. So there's a lot of real-world application of those logs. But at least I want you to remember everything you eat has to do with logs because we measure its acidity, okay, its pH, eat and drink. And everything that you hear has to do with logs. And if there's an earthquake, you'll end up describing it on the Richter scale, which is based on logs. So why are these logs used in these cases? Because there's a tremendous range of sound. Some people, and not just sound, but also of acidity, and also of the Richter scale for like how violent an earthquake is. It's a massive range, and they want to simplify it down to a nice simple 1 through 10 scale. Okay? So if there's a huge range from, there are people who claim that they can hear when they're in a meditative state, in a super quiet room, that they can hear grass growing. And then we have sounds that are so loud that they can kill you. Okay? That's a huge range. Yes? Oh, great.
The cause of air
Embolism. Causes an embolism.
Travel to your heart to kill you, or your lungs might just burst.
Wow. Okay. Yeah, that's a great way to go. Okay. So, I hope that you have a new appreciation for how logs are actually around a lot. And I've been talking to give you a little bit of time to try to figure this out. If you have just been listening, please try to answer questions A and B. Your stomach acid's 0.7. That's actually pretty small. Remember, this is a 10 scale, and that means 0.1. That means it's really acidic. Have you guys heard about this? That pure stomach acid could burn a hole in your carpeting, for example. Like you take a drop of it. The stomach acid that's inside of you right now, in its pure state, when it first is secreted, it's that acidic. Doesn't that feel like it would burn a hole in you then? But your body has defenses for that. It's got a system set up. But what if your system kind of gets messed up? You can get an ulcer. Very good. An ulcer is where the acid in your stomach can burn a hole in your stomach, which then is very painful. It makes it painful to eat and everything. And in the old days, when we did not understand pH well, people said, the best thing for that is if you drink some nice milk, because milk will coat your stomach and it'll protect you from that acid. Turns out milk is acidic. So, and since the problem was an acid problem, you're adding more acid. So that's a great idea. You got too much acid. You know what you should do? Have more acid. So, hey, that's better than back when they did leeches. They were really convinced leeches would draw, and bloodletting. Oh, that's another good one. George Washington, president and founding father of the United States, basically died from bloodletting. No. They let his blood because he was really sick. Oh. Yes. Yes. Okay, go ahead. All right. So, this just goes in, and it's, I hope, pretty easy, because it's just a simple formula. Negative log of, and then I'm dropping in, instead of the h, I'm dropping in the 10 to the negative 7. And why does this not feel right? What's missing? The base. So always write the base down. And that's the clue that goes, oh, these are the same. So the answer's already there. And so the answer to this whole thing right here, not counting the negative, is negative 7. And then now that there's another negative, you have negative of negative 7, which makes it a 7. So they were having us find the pH of water. Make sense? All right. Find the pH of a solution with, and again, this time they've given us a more complicated thing to put in. Instead of just 10 to the negative 7, we got to put in all that. So that's negative log, base 10 I'm putting in. Always put in the base of 6.3 times 10 to the negative 13. Well, if this was just 10 to the negative 13, it'd be easy. These would match and the answer would be 13. But it's not. So how do we figure it out? You can at least estimate it. Log base 10 of 6.3. And this multiply becomes an add. Another one, and don't forget the negative on the front, negative log base 10 of 10 to the negative 13. And all of that we've already discussed is 13. And this part, I'm actually curious. Does anybody have the calculator out? I don't want to bother anybody to take it out, but nobody's got it out? That's all right. I've got one. I can take it out. 2. Yes, it is. Oh, you're using the iPad, which is awesome. Thank you very much. 0.799. And I was going to say it was almost 1, and here's how I could estimate that. Again, you'd need a calculator to get an exact answer here, but do you get that this is kind of close to log base 10 of 10, which would have been 1? All right. Now, I'm assuming you didn't put in the negative, right? So then this would be negative, right? I mean, you didn't use this negative, did you?
No.
On the calculator? Okay. So then, subtract about 1, and then this one is, because this was negative, then we are at 13, because there was 2 negatives, and then this makes it a little less than 13, so like 12.2. Is that super acidic or super basic? Super basic. Now, base versus acid, you would think if you put some base with some acid that it would just kind of neutralize each other. Okay? But oftentimes there's a violent reaction when you put a base with an acid. That's a science experiment they're never going to do with you here at school. You know why? It releases a poisonous gas. Okay? So for instance, if you're at home, and I'm not going to mention even what the chemicals are because I don't want anybody to do this, but there are common household products that if you happen to mix them, they can cause a poisonous gas that can knock you out or, in bad enough cases, kill you just from mixing household products. So bases and acids, do not mix well. Don't do it. All right. I think that's good enough. I just needed you to see a few of these where we have an equation and a word problem. You stick the numbers in and you solve it. All right. I'm going to pause for a second here. All right, this is the part where we're going to go to having a much time to work on the homework. The homework is to do a review. Same assignment as last night, but it starts at this little log cabin right here. But I only had you do like a few of these and a few of those. I think we need a little bit more practice on these. These are not easy, and I want you to be good at them because this kind of stuff on your test. So all the ones that I told you to skip before, some people were like, but which ones did it tell me to do before? It's kind of irrelevant because from here on, from the cabin on, I want you to do every problem that we didn't do before. So you're now assigned all of those except the challengers. I always say you can skip those because those sometimes even stump the math teachers. And all of those, except you do not have to do this whole discussion with your peers and all that stuff. So, and some people were asking about these like, oh, but the IB questions must be super hard. Now this says 2 minutes total should be able to do this whole page. Now I know that's an exaggeration, but that's implying the teacher looked it over and said, these are not hard. These are not super hard. If they're too hard for you, you're not understanding what they're asking you to do. All right? So basically, they want you to rewrite it as a log, and it'll have B and C in your answer. Okay. Now, one thing that people need to remember about square roots, C square root is the same as C to the 1/2 power. That's really handy to remember. Square roots are the same as to the 1/2 power. Okay. And when you put 1 over something like this, do you know that that's the same as C to the -2? 1 over in a power means that it's a negative power. That is the same as that. And that helps because then when you're rewriting it as a log, you know, it's a lot easier. Okay, so your homework is to finish up this section, and because we've spent so much time on this section, we're definitely going to be looking at grading this thing tomorrow somehow. I don't know if I'm going to pick certain ones and spot check, or if I'm going to have you drop in the Dropbox, or but just we spent enough time on it, I need to grade it. So that's part of the plan for tomorrow. And that's all I have for you for today.